Strategy Design Pattern by Daniel Craig and Brian Robertson.
The strategy pattern is a way of decoupling an algorithm from the objects that need to use them. When we work in object-oriented programming, it's important that we be able to expand the capabilities of our program and specifically of the objects in our program without having to worry too much about having to go back and refactor all the way that we've organized the structure of our program so far. And this gets at an idea called decoupling. When a program is loosely coupled, it's easier to reuse the code and it's easier to expand it. So that's what the strategy pattern is all about. Specifically in Java, this takes the form of interfaces that extend and expand the capability of a class object. So for example, if you wanted to implement an interface in your Java class, you would simply put the name of the class followed by implements and the name of the interface. And then in that interface, you would define behaviors that class object would be able to do. And to be a little more concrete, a little more specific, these would be alternate ways of doing tasks that class object would have to do. We'll get to in a moment. We'll get to the example of a car, but think about a car, and in a video game or in a simulation, really just the idea of a car in general. If you wanted to swap the motor of your car, that changes the capabilities of your car. The strategy pattern models this behavior very closely within programming, so that even outside of the context of a video game programming situation, you can expand and add to the capabilities of your objects. Like I say, in the strategy pattern, the algorithms are swappable, making it more possible for the program to be flexible. That's really the whole idea of it. So you can see that. So a moment ago I mentioned the example of a car simulator. Think of a car as you know it. The parts are all interchangeable. The parts are all swappable. But more than anything, what should be noted about the fact that the parts are interchangeable is that as we change those parts, the abilities of that car changes. If we install a new motor, we might increase the horsepower of our car. If we install new brakes, we might increase the braking capability of the car. If we install the ability to use boost, for example, specifically in the context of a video game, or other such abilities to a car, then you can start to see how it'd be in our interest to have these things loosely coupled from the car itself so that we could swap them without too much concern for the actual car itself. We want to be able to make this as loosely coupled as possible, simply so that we'll have greater ability to add new abilities and even change abilities during the course of execution of this program. To call attention to the UML diagram that I have placed below, you can see that the context really is just kind of a stand-in for the class object itself. So it provides context for this strategy that's going to be used. In a way, this is similar to polymorphism, but in sort of a different way. It's not an inheritance. It's more like adding a new capability onto an object that already exists. So you can see that this context class implements an interface called strategy. And this strategy is just that. It's a strategy for accomplishing a specific task. There can be multiple ways of doing something. There can be multiple algorithms for dealing with the data or the construct of our class object. But in essence, the idea is that the more loosely coupled these objects are from the strategies that they use to accomplish things, the more that we can expand our program on the fly. So just like I was saying about an example of a car, we could make this car, we could swap in new parts to make it boost, to make it fly, to make it go underwater, and that same kind of extensibility applies to any other application of the strategy pattern that you might find, whether in business or in any other field. It's not exclusive to video games, of course.
Upsides. Testing. Code using the strategy design pattern is easier to test because, in general, the code segments are more independent of each other. Modification. It is easier to add new algorithms to code using the strategy design pattern because you can just make a new class for the algorithm you want to use, and often you won't have to make any changes to the base class. Code reusability. Because the algorithms you have already used in your program are all encapsulated in their own classes, they can be called from anywhere in your program without having code duplication. Organization. The strategy design pattern can help you keep track of all the algorithms you already have available and make it easier to call them. Downsides. Complexity. In some ways, the strategy design pattern can be seen as being more work or more complex because you need to create separate classes for each algorithm you want to implement. Sometimes there can be too many options. Having options is good, but if you have so many different algorithm choices that the client doesn't know which to choose, your program can suffer. More work up front. The strategy design pattern can be more work up front. However, this will depend on the type of program that you're writing. And in the end, you can save time in the long run, but this is something that needs to be taken into account while planning your project to make sure you're making the best decision. Recommendations. The strategy design pattern is meant for programs where you need to choose from a set of different algorithms based on the input provided by the user at runtime. It is most useful when the behavior of your program needs to be reactive to the input provided to it. For example, a strategy design pattern would make sense for a program that takes an array of data and then sorts it with an algorithm of the user's choice. It would make sense to have each sorting algorithm in its own class, in its own container, rather than just hard coding all the sorting algorithms directly into the main program. Thank you for listening to our presentation on the strategy design pattern. We hope you learned something.